See Lindelof videos, radical equations part 2. So, got this question, so I'm going to just follow this for a little while. I'm going to actually do a couple more of these, I guess, today to try to get to an answer on this. So, here we have this radical equation. How do we know? Because there's this radical, and this is the radical right here. Most people have heard it called the square root sign for most of their lives, but it's actually more accurately called the radical. And this happens to be a square radical. When you see a radical like this, you see this. If you don't see a number in there, if you don't see a number here, you assume the number 2. So we can assume the number 2 is here, and the number 2 is here, etc. ad nauseum. And what I really want to make sure that you get is that because of the rules, the order of operations in mathematics, if something is under the radical, it's especially if it's in the form of terms, it's very hard to get it out unless you remove that radical. So having said that, that's where we are. We're going to do our algebra the same way that we normally would, and that is to say if there's something added or subtracted to the equation, we're going to add or subtract its opposite to both sides. So in this case, as I pursue this, I'm interested in this piece right here, but I realize that first thing I have to do is get rid of this negative 8. So to get rid of a negative 8, I add a positive 8, so I add positive 8 to both sides. And then we get this square root. Remember, I'm just going to write this so we can see it. Square root of 5a minus 5 is equal to 5, isn't it? 8 minus 3 is 5. Now comes the part that's really important to us. This is the part that helps us move forward with our math. I see this square radical, right? The square root. This, too, causes me to do this. So this is what I know. If I square a square root, it cancels the square root. And I can give you some proof of that. Maybe some easy proof of that would be the square root of 5 squared equals 5, doesn't it? If you think about that, 5 squared is 25. The square root of 25 is 5. So the square root of 5a minus 5 squared is just this inside piece, which happens to be called the radicand. So as I do that, also I'm going to remember to, if I square one side, to square the other side also. That takes us to our next step, which is that this gets rid of this and leaves us with just the 5a minus 5. 5 squared is 25. Now this looks like a more ordinary Algebra 1 problem, doesn't it? So here I'm just going to pursue getting a by itself, so I'll add 5 to both sides and get that 5a is equal to 30. And if 5a is equal to 30, I divide both sides by 5 and get that a is equal to 6. So I hope that this is really helpful. I hope you're getting this. Here, this problem is also very interesting, and it's another sticking point for a lot of students, it seems. So I look at this way. This is 10 times the square root of 9x. This is 10 times this value. So I look at this 10 as if it was a coefficient, and I'm just going to divide both sides by 10. Divide both sides by 10. 10 over 10 is 1, and 1 times square root of 9x is the square root of 9x. And 60 divided by 10 is 6. So hopefully we can agree on that. From here, I'm going to notice that thing that I keep preaching to you about today, and that is that I see this square root, keeping in mind that there's a 2 there. Even if I don't see it, the 2 is assumed to be there. So to get rid of that, to get rid of this whole piece of purple cage here, I'm just going to square the whole lot. So that's me squaring it, which, remember, given this example right here, leaves us with just 9x. Important that we squared both sides, and 6 squared is 36. Our algebra should be relatively simple here. Just divide both sides by 9 and get x is equal to 4. Isn't that right? So there's our answer for number 10. All right, maybe we try one more. Can we try one more? Sure. Let's try this one. I think you can figure this one out, can't you? Let's try this one. This one, what am I going to do? I see this. This is 10 times this value. I'm going to divide both sides by negative 10 and get the square root of v minus 10 is equal to negative over negative is a positive, and 60 divided by 10 is 6, isn't it? So keep moving on. Number 12. So again, this is the last video I'm going to do this in. But again, I'm keeping in mind that there's a 2 here. So to get rid of that, I'm going to square both sides. And this square gets rid of the square root, leaving only the radicand, or the piece inside, v minus 10. Now you free up that 10 to be moved over, 36. And our answer should be, I'm going to add 10 to both sides, v is equal to 46. All right, you guys? I hope this is helpful. This is really, really important math. I cannot overstress how important this is. Thanks for watching. If you have any questions or comments, please let me know. And if you haven't already subscribed, please